let's have a look at the second version, the client server ports. You see, they look a little bit different. While sender receiver is this triangular shape, now we have a circle and a half circle. So that's the way you differentiate between those. Client server ports are used for our control flow in our system. So these are ports which can request operations. How do they work? The way they work is you have a software component which acts as the server. In this case, will look something like this. It will have such a circle-shaped port, a server port, and then you have ECUs which connect to the server in the form of software components which connect to the server in the form as clients. I can now request the server to do things, to perform operations. In its simplest form, this just means this part of the software calls a function on this part of the software. There's a little bit more to it, and you will go into way more detail in chapter 2, I/O, about this topic. Now, instead of now having data elements attached to these ports, we now have operations connected to the ports. So every server port offers different operations to the clients. So give you an example. Let's say you have this component and this component is capable of, for example, calculating logarithms. Then it can have a port. Let's say this port is named logarithm, and it can have several operations connected to it. So similar to how you can have multiple data elements, you can have multiple for sender receiver ports, you can have multiple data operations on a client server port. So you might have, for example, on this logarithm port, an operation to calculate the binary logarithm, to calculate a logarithm base 10, and to calculate a natural logarithm. And you don't need a separate port. You can have one port that offers all these operations for you. And if you are the client, you can simply say, okay, I have some data. Please, server, calculate for me the natural logarithm of this input data. And then the server will do this and will return with the data. This communication can work synchronously or asynchronously. Synchronously means the client is blocked while the server performs its operation. So the client calls, is blocked, server finishes, returns, client continues. This is very similar to the classical function call in C. You call a function from another function, well, that function will be blocked until the called function returns. Asynchronously means client dispatches a job at the server and then continues running. And once the server is finished, then there are different ways of returning. Either the client can now pull the server state, or the server notifies the client that it is finished. Different ways of how this can be configured. In terms of how the API looks for the client-server communication, it will always be something like RTE_call, name of the port, name of the operation. Very similar to here, name of the port, name of the data element. But instead of RTE read write, it's just RTE call. These calls, the way in which these names are built up is standardized by AUTOSAR. So now we have established how these software components. Oh, one more thing. Similar to here, how we can hear one-to-N, how we can have one-to-N or N-to-one communication. Here with client-server communication, we are limited to either one-to-one or N-to-one, meaning you can have many clients connecting to a single server, but a client can always only connect to one server. So if you want to connect to multiple servers in your software component, you need multiple client ports. And one more thing I should mention, software components are not exclusively limited to being servers or clients. So it's perfectly valid that this software component has a server port and it has a client port. So the role of server or client is port specific, not software component specific.